Actually, I'm really happy that many of you just in your assignments already play with this if. And if you did that, of course, I think many of you remember that from Python or something. So it is really common. It is kind of start of programming when you have conditions. If this, then do that. Else, do something in other. So we will really talk about this subject today, but we will wait a few minutes. But yeah, what I want to say to you. Actually, some of you never programmed before. And for that, for those people, I would like to say, so be really energetic this week. Because we have two main subjects here. It is conditions and another one which? Loops. Conditions and loops. So this is the most basic and the most fundamental subjects, the most fundamental topics for programming, but they could be a bit hard or difficult for understanding. And of course we have just few projects regarding that topics, but it is so important for you to jump into that. So I could consider this week like very fundamental week for you. Really fundamental. You have readings, you have projects, you have lectures, you have videos. Please work through that very carefully, because if you lost this week, you lost everything. Because you can't be a programmer without understanding conditions and loops. It is so basic, so fundamental, so important. So if you lost that, you will lose everything. So please be careful. I just thought, oh my goodness, just 1 week for these two crucial topics. This is the question: is it possible to learn programming in 7 weeks? And we say yes, it is possible, but it is kind of not so easy. It is true. Okay, I will prepare my whiteboard while I prepare this lecture. So we will work with flowcharts. So I will create map here now, like symbols, what that mean. So we will draw such figures to create algorithms. And I will tell you more about that, but let me just start and prepare some mapping information for you to understand. So we will use these figures. And I'm interested, could you online see anything? What
Yes.
Okay.
Yes.
Amazing. Okay, so please notice these symbols. You should understand, you should know that it is flowcharts. We use that for flowcharts. And flowchart we use to create algorithms. And why it is important? Because it is so connected to our today's subject, which is conditions, or if-else statements, or branching. When our simple program could be divided into different flows. That's why flowchart, like our algorithm could be implemented, or our user handling could be implemented in this way or in another way. Algorithms help us to do that. For example, yeah, let me explain. So this oval, or how to say, how ellipse, I don't know. So we use for and start and end. Starting from this and finishing by this figure. This is just a process. So this is just when program do something. Process. This is input-output. When we want some variable from user, or when we want to show user something. This is just logical flow from one figure to another figure, and this is the most interesting stuff. Diamond which is used for conditions, for ifs. For example, is Tuesday, and we have two outputs from this diamond, true and false. So if it is Tuesday, then I don't know, I want to output, we have SDT 100 class. If it is not Tuesday, okay, it could be Thursday, of course, but let's simplify. We don't have SDT 100 class. So it is output, and then our program just finished. And here we could put start, of course, and so on and so on. But this is the idea how diamond works. So diamond have one inner connection and two outer connections. So please remember that. We don't have 4 connections. We don't have 2 connections. We have just 3 connections. One input connection from previous operations, one question. It is good to put question here. And this question could be answered like yes or no, just 2 answers. We could not answer 3 different answers. It is just true or false. You already know what is true and what is false. True, false. And then we decide how to write our program after that answers. So this is the just a simple idea of diamond. So in flowchart, the most interesting is this. That's why we're talking about that. So let's try to create some flowchart, some algorithm for us in real life. Could you please share do you have any ideas? For example, I wake up, and if I feel not very well, I will make a coffee, for example, or I don't know, or something like that. Do you have such ideas? Let's create some kind of flowchart together. Yeah.
So after the class online, if true, then I stay home. If false, then I go to campus.
Yeah, that makes sense. Okay, let's do that. So we have a program, or not program, let it be just real life, because with flowcharts, even project managers or just business managers, they also use flowcharts, not only programmers. So flowcharts, it is quite interesting thing, which is useful for many cases. So, okay, start. Okay, we just start. Then, yeah, so it is, if it is just real life, then we have no variables, input, output, we just have some real life activity, wake up, for example. Then, am I online student? Question mark. True. Repent and become offline. Okay, no. Stay home. It was for you guys online. Are you listening? I see these black boxes, by the way. Okay, stay home. If false, I'm not online student. Then I go to campus. And so on and so forth. So we could finish our program here, or not our program, but our flowchart, our algorithm. So with this algorithm, we just describe our kind of general day. Yeah. So it is possible to describe our algorithms through these flowcharts. And for example, let's recreate this flowchart in a real program. Let's ask student or user online, let get this input and let make some output. So let me create something similar which we just created for real life example. So we start our program. Then let welcome to our program. We could output some welcome message to our user. And then we ask user input study mode, no, online mode, let's say. Input is online. Let I have variable is online, boolean, and I ask my user to input value of is online. Then I have the same question, is online. I check value of this variable, and if value of this variable true, then what shall we do? What are your ideas? If it is online student, what should we do? Huh? Output stay home, yeah? Okay, output something like stay home, buddy. And if we have false for this statement, I'm not online. So what shall we do?
Go to campus right now.
These are passive aggressive.
Go to campus, man. All right. And so on and so forth. By the way, we could have some additional conditions over there. We could ask, so our program could be really like a tree. But at the moment we could finish. It is enough. In such a way, we could create and visualize algorithms in our head on the piece of paper or in a program. You could use program for that. I will show you how to deal with that. And after that, we could create just the code. Yes?
If we put an exclamation mark for the variable, do we check like the opposite of the true or false? So we're checking if it's not true or if it's not false. Because
Yeah, exactly. So, like, what the essence of the question? What means exclamation mark?
I was confused in this. Like, what's the logic of this?
Exclamation?
Yeah, like before in particularly boolean variable, because it's like changed the variable, or
Yeah.
just checked.
No, it just, yeah, good question. Yeah, I need to tell a lot of stuff to you guys. Yeah, it is a good question. Please keep it. And now just I will move to syntax, and that question will make really sense in that syntax. So we have this flowchart, and we could implement this flowchart in code. And I will try to write here, and hopefully guys online will see this. Whiteboard also. So we have, yeah, of course, I could create this code in my IntelliJ IDEA, but let me use whiteboard this time. Okay, so I output. So I create my class, main, all this stuff, and I will output. So sorry for this sound. It is system out println. Okay, You remember that. And welcome. And yeah.
What difference is print LM and print?
And printf. Yeah, so printf, it is formatted print, and it has some specific syntax how to print. You could put some stuff inside the print, and it is the way how we format the print. So it is the way how we put variables inside our print. So when we use just println, how we combine with variables? We just put plus and our variable. But when we use printf, we put specific just marks inside of that, and then use additional parameters for this printf. So it is just way how to output variables. But I will not jump into that because it will take time. But you could use printf also. It is good old-fashioned style to print something very convenient, I would say. Okay, so we print welcome, then we ask user to input variable. So first of all, we create variable boolean. Boolean is online. Is online. So we just created this variable. Then we again system out println. Are you online student? So we ask this question, system out println, and then we get an answer from our stuff, like we get answers from the user. So I should create a scanner before, you remember that? Yeah. And then put like my created scanner in next boolean. And so on and so forth, and then next line here. So, but the essence that I get this is online from user input, which is nice because our program become interactive. Okay. So, and the most important question now, which many of you already done in your works, is how to implement this section of our algorithm. And you know that we use if. Okay, guys online, do you still see the whiteboard?
Can you show us all if?
Yep.
Like,
Yeah, thank you. Huh?
Can you show us it on IDE?
Yeah, I already started here, so let this algorithm be on the whiteboard. So, excuse me, but it may be a bit easier to explain you some stuff. Yeah, but I could use IDE in next code, of course. So, if is online, then do something.
Can I ask a question? Why do we have boolean is online but not
Else? Yeah, just a moment. I would like to represent you this common syntax for if-else statement. And now you should pay attention, especially people who work just with Python. I know all these brackets, it is kind of something new for you. But it is Python, which is kind of new stuff without brackets. But always programming had brackets or something, or in Pascal, begin end. But just Python, they decided, oh, it's a good idea using just indents, which is really brilliant idea. But still, the essence is the same, that you have some block of code. And if you have this block of code, you should use brackets. parentheses for that. This one and second one. I mean, I open the brackets, I put several lines of code, or many lines of code, or 100 lines of code. And I will know exactly that it is corresponds to this if when we have true here. And this brackets is so important. Of course, you could make it without brackets, but only in one case. When I will not put brackets here. It is case when I can do without that.
We can use the question mark in the
Not sure. Another versions?
If it's only one statement inside.
Yeah, if it is only one statement, or it is in human language only one line of code, only one line. If here only one line, I could leave, I could not use these brackets and it will work correctly. But if I have two lines and will not put brackets, then only first line will work, and this another line, because brackets could grow many lines like in one block of code. It is called like block. So without brackets, only one line could be this block. So that's why we use brackets. So Python programmers, did you understand that? That's funny, yeah.
Yes.
So brackets are important, or parentheses. Another brackets, which is really important. As I remember in Pascal, we could not put brackets here. If I'm mistaken, please fix me. But I'm not remember exactly. But in C-like languages, with Java is C-like language, we always use these rounded brackets here and put condition here. And this condition, result of stuff which is here, is always should be Boolean. In Java, it should be Boolean. Okay? So every condition will be compiler will consider this as a Boolean. Okay. So inside these brackets we put condition, and there is very simple rule here. If this condition is true, then first block of code will be executed. If this condition is false, then second block will be executed. By the way, second block could be absent. It is also possible to not have this false block. We could create this algorithm just without this, just only one branch. It is also possible. So that's why when you ask the questions about exclamation mark, if I put exclamation mark here, what will be changed in this program? So in this case, we will have opposite results. So this block will be kind of executed here, but this block will be executed there. Okay? So this exclamation mark, we just need to calculate this Boolean expression here. It could be different Boolean expression. For example, I could, okay, let's talk about that in human language. I could say, I need, for example, I need to go for a walk. And I could logically decide for myself, if it is raining, I will not walk, okay? It is kind of logical, good decision. But maybe it is so hot, 35 degrees, or 40, or I don't know how much, 50. It is so hot summer. And I could decide if it is rain, I will go for a walk. Yeah, I could decide that, right? So it is possible. So I just changed my mind, and that's why I decide if it is not raining, I will go, or vice versa. If it is raining, I will go. So all this Boolean stuff, logical or, logical and, not, which is exclamation mark, I group all of that for some logic and create this logic here, and for result of true, create this block of code. So it is syntax for if, and now let me create a proper program for that. So if is online, then stay home. So I just write this code. If is online, then, sorry for this slang language, then output stay home. And then I close the brackets, but I have another branch. I have this false condition. So that's why I create else, and again open the block of code, and I should output go to campus. Print len go to campus, and close this. Okay? So that's why, what is correspondence, what is mapping between this code and this? So this true, it is this branch, and this false we have here. That's why you understand that if works like this, and else work for another branch. Do you have any questions regarding that? And because of here we have only one line of code, right? For every condition. I could delete my brackets and my program will work properly. So it is also correct, because I have just one line of code here, just one operator, or one expression, and just one operator here. By the way, I need semicolons here. So it will work correctly for like this algorithm says us to work. But if I need more lines, of course I should use brackets. Okay? Okay. Let me show you another example, which is, I suppose, really needed to show. So, for example, we ask our user to input their program name, like BSc, MSc, Bachelor of Data Science, and so on. So we could input that. Input program name. Program. And then we could have very different situations here. So for example, we could check if it is BSc student. Then we could check if it is data science student. Then we could check maybe it is master's student, and so on and so forth. So for example, I have this program, equals BSC question mark. True. If it is BSC, then we say something, oh, okay, you will be software engineer and so on. We output something. If false, because so we want not only check if it BSC, we want also check if it Bachelor of Data Science. So we have another check. Program equals. Do you see what that means? You should know after this first program. Equals how we compare strings. We do not just put equals, yeah? But in Java, to compare strings, we should use variable of string dot equals method, and then put another string which we want to compare. Okay. So that's why I use equals, but I could use for human language, I could use for you to understand, I could use here like program equals BDS question mark. So this is the essence of this, but it is more Java code, it is more human language code. In Flowchart we could use human language, but for you it is important to understand what you want to accomplish. Okay. So now our program have two ifs, and it become more interesting and more complicated maybe. So if true, for example, let's go here. Again, we output something. Oh, hello, you will be a data science specialist. But then, how deep we would like to deal with this user input? We could put another diamond and more and more and more. Well, let me stop here at the moment. So it is false. And we just, in this case, we could output also something like, we don't know who you are. What are you doing here, for example, yeah? And all these lines go to the end. So this is another way how to create algorithm. So do you see sense in this algorithm? Do you understand that? Yeah? Do you have questions? Yeah.
We don't have to create with this only ifs, right? Is it going to be, let me rephrase, is it going to be hard to only just use if in the program if we do like this thing?
Yeah, so this is the aim of this code, to show you how to program that at the very end. Yeah, we have interesting construction here. So how could we program this construction?
What if we program it with switch?
Yeah, switch it is another way to do things, and maybe you will know about switch by yourself. And but my aim now is to show you how to deal with if-else in this situation. So in this situation we have this if program. Well, we already get that program from user input, and program is string. For you to know just that it is string. Okay. Program equals. So our first condition, we are here. BC. And one more bracket, this, and this bracket. So be careful with all these brackets. And we have first output, this one. I will call that first output. So this piece of code should be put here. Then what should we do? We accomplish this true branch, but we have false branch. And in false branch, we have interesting situation because we have another condition. How should we handle that? We could do that in such a way. Of course, we could do this, by the way. Else, open brackets, and inside write another if. And deal with that. It is also okay to do that. We could do like this. So between these two brackets, we could do everything we want. And we could put another if everything we would like to do. It is possible, it is okay. But another way to do that is to use just on the fly, to use this another if near the else. So we have else and put if just here and put another question here, this one. So program equals Bachelor of Data Science and open brackets and put this second input here. Second input here. Then close the brackets. And as we have this another, like third output here, we could also put it. And we should put another else. And it is our third output here. And close the brackets. Yeah, this is it. Could you see this code? Could you see this idea on this code? So you should understand that. If first condition, first output, else, and if just here in line. Another condition, and for true, we have this second output. If this is false, then third output will work. So this is the idea how we could deal with this stuff. Okay? Does it make sense?
Yes.
Okay. Of course, we have another syntax which I really not planned for you to explain, but you should play with that in home, and work with that. It is switch case. When we could have, for example, we could have, let we have some chart for choice, for user choice, and we could switch our choice, and we could have many cases. 10 cases, for example. Because for 10 cases, to write if else 10 times, not so useful. So we could use this kind of. But I could say that you should, of course, know the switch case. It is so important for you. But in real programming, switch case is not the best variant to program. So it is kind of really edge case, I could say. Yeah.
There is need to be break, yes? In
Break?
switch case.
Yeah. You should have case and you should have break after the each case. Break. Yeah. So maybe you know that from other languages. So. Okay. So my aim is to you to explain that, and another thing for you to explain how to work with these flowcharts. Could you please Google Lucid Spark or just Lucid? So what I want for you to have, you see this, yeah, so guys, sorry, not Lucid Spark, but Lucid Chart. Lucid Spark and Lucid Chart, it is systems connected with each other. Lucid Spark is a bit newer system, but I found flowcharts more convenient in Lucid Chart. So that's why please play not with Lucid Spark, but with Lucid Chart. And choose this template with flowchart, and you should have this panel flowchart. If you see my pointer, this. Okay. So how to create this stuff? Let me show you. I take first like start, then I could move this arrow here and choose what I need. I need process. So process is just a square or rectangle. So I don't know, I make something, like create variable. Then, for example, I move on and create something else, like input output. And I choose input output stuff. Yeah. Input output here. And then I need some condition, for example. So I use diamond. Question mark.
IO is input output.
Yeah, yeah. So, and I have these two different variants. How to, come on. How to work with that. Or I could use this panel to add another figures here. I can do that because I have too much figures, so I will delete all previous templates. And so I put it here, and I have some process, and I have another process. So by the way, guys from online, do you see my screen?
Yes.
Super. Okay.
Yes.
Yeah. Okay. Okay, so this is our practical work now. Let's play a little bit with that. So let me give you a task. So could you please create diagram with your own logic? So decide. You could implement this logic. It is default, this idea. Or you could implement a different logic. So create flowchart and create Java program for that flowchart. This is your task for class, okay?